Robots, a term we are all familiar with. Although there are varied definitions of the term, they all agree that there is some level of autonomy involved during operation. Due to this autonomy, robots must be programmed in such a way that they are capable of making decisions on their own. In the context of mobile robots, this autonomy comes in the form of closed-loop motion control. This is the process where the robot continuously receives feedback from its sensors and adjusts its movements accordingly to achieve the desired outcome. Introducing Mona. Developed by the University of Manchester, it is a two-wheeled robot that contains 5 infrared sensors allowing for obstacle avoidance. Envision a scenario where we need Mona to adhere to a certain trajectory. We can implement an open-loop control design, and using calculations, it is possible for us to simulate the robot following the route. However, this is purely theoretical, as in the physical world there are many uncertainties such as terrain conditions, sensor limitations, and power constraints. We can simulate these uncertainties and visualize how Mona handles them. It can be seen that there is quite an obvious deviation in the path due to these uncertainties, and depending on the application this could lead to an egregious error. Therefore, there is a need to reduce this error in our open loop design. This is where closed loop control comes in. Including a feedback PI controller in our design, we are able to ensure precise and accurate motion of the robot. So now that we have a controller in our design to mitigate the effects of the uncertainties, let's change our simulation so that Mona travels on a path A to B. Although not exactly linear, Mona eventually reaches the destination. If we compare this to an assumed path with no uncertainties, the error due to our controller has an exponential decrease over time, with the final error being minuscule. Incorporating a position planner allows us to set waypoints for Mona to follow before reaching the end position. If we initiate Mona with the controller from the previous simulation, we get the following. However, different applications require different controllers. For instance, we can modify the PI control parameters so that the robot follows the path exactly. This type of controller can be used in the manufacturing or medical industry, where it is crucial to follow the planner exactly. We can also fine-tune the controller so that the robot takes wide turns around sharp corners. This would be ideal for delivery robots or carriers, as this would reduce the risk of packages falling or breaking due to collisions. Mobile robots necessitate the need for closed-loop feedback. Because of their ability to tackle uncertainties and their adaptability to changing environments, controllers enable mobile robots to navigate, manipulate objects, and perform tasks with greater accuracy, adaptability, and robustness in dynamic environments. Thank you for watching.